Hello everyone, welcome to a new episode of HVAC Education Hub channel. In this episode, I will try to explain one project or project revision, what we received from customer, and I want to speak a little bit about all this design process, heat loss calculation, underfloor heating design. I will mainly focus on Croatia because I'm here, I know situation here, but I assume in other countries it's similar, regulation is similar, technical norm is similar, and design process is similar. But let's see this example. So we have one house, new build, design outdoor temperature is -6 degrees Celsius, and house is 250 square meters big, and let's say indoor temperature is 20 degrees, just to know what we are dealing with. And in this project, heat loss, calculated heat loss was 30 kilowatt. So 30 kilowatt, if you ask me, there is not a lot of houses with more than 16 kilowatt heat loss, which is, let's say, maximum heat pump capacity for residential buildings. So around 16, and this is not such a big house. For example, if it's 500 square meters, okay, we can deal with that. This is first strange thing. Second strange thing is for new build in Croatia, if you want to have construction permits to build your house and to have everything legal, you need to follow NZEB standards, so nearly zero energy building, like in EU, and you need to follow some steps. Few of these steps are insulation, so you need to have proper insulation of walls, you need to have proper insulation of windows, or basically U values of the windows or the floors, and you have maximum U value which is permitted to build your house. And if you put everything what I mentioned, you will hardly have more than, let's say, on -6 or -7 or -8, more than around 60 watts per square meter. So this is approximation. This is more or less what you will have at -10, let's say. At -6, even lower. What we have here, if we divide 30 kilowatt or 30,000 watts with square meters, we have more than 100 watts per square meter. So this is not legal in Croatia, so you cannot build up your house with such a high heat loss. Even for reconstruction, you will hardly find house with such a big heat loss. Almost all of the houses has at least new windows, at least some form of insulation, even indoor or outdoor. So this is basically not on the same page with design. Another thing what I need to mention is that also in Croatia you need to have energy certificate, or you need to have some, let's say, ID, energy ID of your house. And in energy ID of this house, it was calculated that heat loss is approximately 9.5 kilowatt. So you can see this is 30% of this 30 kilowatt. Let's say that this is also wrong, that it's not 9.5, that it's bigger. Let's say that it's, for example, 15 kilowatt. 15 kilowatt. This is still half of the 30. And this is the main thing when I'm talking about oversizing units. Most of us in the industry can agree that oversizing is not good for heat pump. I'm not talking about oversizing like 10, 20, 30% if you need, because you need to choose equipment and so on. But if you oversize by 50, 60, 100 or 300%, you will for sure have bad system, bad unit, high consumption. What is the main thing here? This 30 kilowatt minimum modulation is around, let's say, 7, 8 kilowatt or 9 kilowatt at some point. On minimum, it's more than this house it's losing on design outdoor temperature. So this unit will always work on and off, always, and minimum electrical consumption will be really high, because with 10 kilowatt you will spend really high amount of electricity. Even if outdoor is 15 or 5 or -10, you will always spend a lot of energy. So this is this one project. Customer approaches and say, yeah, it's for me looks too much. We redesigned it with our partners. But additional point, what I want to mention is underfloor heating delta T and heat pump delta T. This is related with this one because in this project, underfloor heating was calculating with some bigger delta T, with some strange numbers, strange areas, because for this surface of the house, probably you cannot have underfloor heating because temperature of the floor will be too hot. And also, what is with heat pump delta T? So we cannot calculate underfloor heating delta T and say, okay, in one room we will have delta T 5, in another room 7, upstairs we will have delta T 10, on the bottom we will have 11, because all of these pipes are coming back to the heat pump. And heat pump or the system, even its boiler or the heat pump, so heat generator, has some delta T, some flow and return. We need to ensure that our whole system, even its underfloor heating or radiators, has this delta T, and we cannot play with numbers like that. Also, we also have discussions about that. Is it better to calculate heat loss by hand, so let's say old-fashioned way, or to use some good softwares? Today there are excellent softwares. Beam, Cyp, Heat Engineer for guys in UK, really excellent softwares. But still, software is here to help us, but we need to know what we are entering in the software. So if software says, okay, we have 30 kilowatts, we need to know that this is new build. We are dealing with much lower watts per square meters from experience and from some previous hand calculations. And then we need to say, okay, probably we put something wrong in the software, or we forgot to define the windows. We don't have windows, or we have wrong U values for windows. Then we need to say, yeah, this is the same is with Excel files or with whatever. Software is good thing, but we need to know what we are dealing, and we need to know what we need to expect from the software. So this is really extreme case. There are a lot of other projects with really oversizing and similar things, but this is extreme example just to show you what is the impact on the customer, on the end user. End user will buy really expensive heat pump, big one, probably you need big place to put it, you will have bigger noise, you will have bigger pipes on the system because you need to calculate on this, you will have high consumption. At the end, customer will say heat pump is bullshit, technology is not working. Not, technology is working, but we need to know how to understand technology. And this is what I'm trying to do, to understand better what is going on, what is behind the software, what is behind the logic, behind the control logic. And that's why discussions on LinkedIn, here on YouTube, in person, wherever, is good. And you need to always challenge. I'm only showing examples and my experience. Maybe it's not 100% true. I'm always trying to check all of this data, usually talking from head, but I'm always trying to check this data and to explain what is going on behind all of this. Thanks for watching. Hope you enjoyed. Follow me on LinkedIn when I'm writing newsletter every Wednesday. Follow me also here on YouTube. There are some big projects ahead, some big ideas. We'll see what will be at the end. Thank you for watching, for subscribing. Thank you for feedback, because I really appreciate every feedback, and see you in some of the next episodes.